Welcome to chemistry. I'm your tutor. My name is Tutor Black Adam, and we're going to do chemistry, the first law of thermodynamics. So it's all about the internal energy of the system. Now, denoted by delta E, and then we have Q. Q, it represents the internal energy, and then whether the energy comes in or out, and then the W stands for the work done on the system or by the system. So the Q, energy in or out, so that's for Q, that is heat for energy coming in the system, and the system can also release energy. So the energy comes in and out of the system. And then the work there is the work that has to be done, so that is work that is done. Okay, so it's gonna be done on the system. I'm using S for system, not entropy. So that is work done by system or on the system. So if it's by the system is losing that energy. If it is on the system is gaining that energy. So let's do question 1. Go through the problem. You can pause as it says that given information that Q is 0.763 kJ, and then the W is -840 J. So there's a difference of units there. So you remember we cannot add different units. So we have delta E there, Q plus W. So given fact there is Q is 0.763 kJ. And then we're gonna find out what else information we have for W. And W there, which is the work done by or on the system, is -84 J. Alright, so the unit is J, not kiloj. So in most cases the energy has to be in kiloj. It's not specified, but that's the standard. So the work there we have to convey it. So a kilo means 1000, so we need to divide 840 J, we divide it by 1000. So defining that by 1000 gives us it should be negative, should be negative 0.840, should be 840 in that case. You can also punch that on the calculator to confirm, and then now it becomes kiloj. What else we check? We also check the equation. So we now have the right equation is delta E is equals to we have the Q there. Our Q value is 0.763 kiloj. 763 kiloj plus negative 0.84 kiloj. Alright, so we add that together. Adding that together, you can punch that in a calculator. That's 0.763. Okay, and then plus times negative is negative 0.840. Let's do that calculation there. Let's go through it. 0.763 minus 0.840, giving us negative 0.77. So it's going to be negative 0.077, and our unit once again, that's our confirmation, our unit is kiloj. So that is the answer for the energy. I just say that calculate the internal energy. And then the question also says that determine if it's endothermic or exothermic. We go to the equation. So this is the equation that we're gonna take. We can see that to determine endo or exo, we need change of enthalpy. Okay, so change of enthalpy, that is change of heat of reaction in that case, is also going to be equivalent to the change in the internal energy. So that is the current value on the internal energy. So that is P, the subscript P is for constant pressure. So at constant pressure, so that is the energy, because the energy is determined by the pressure and temperature. So in that case, Q is going to be positive, and then that means that it's going to be endothermic. So when coming to the internal energy, we concentrate on the internal energy of the system, the current internal energy of the system. So that question there makes us that Q is positive, and then the whole system is going to be is positive there, so it's going to be endothermic. So it's not like you only check on the internal energy of the system, so that's endothermic. So that is done for our part A. So part A is done. Okay, and then endothermic also means that the system managed to absorb heat or energy from the outside of the system. So the outside of the system is the surrounding. Anything else that is not part of our study, it means that it is not what we are accounting for. Alright, so what we're going to do now, we're going to go for B. So let us look at the information that B. You can pause and go through that. The system releases that amount of energy to its surrounding. Okay, so for its surrounding, it means that if it releases, so release means it goes out of the system. So going out of the system would mean that we have 66.1 kilojoules, and that will mean that our Q there will be negative. For releasing, it's negative. So remember, it's about coming in and leaving. So if the energy is leaving the system, all right, energy leaving or coming in, that is Q. Work done by or out of the system, work done on by the system, or on the system by the surrounding. So W on the system is going to be positive, all right, based on the information. Then we go there and find out what the value is. Heat released to the surrounding, so that would be 44.1. So 44.1, and then kilojoules. Okay, so that was work on the system by the surrounding, so that's positive. On the system is positive, by the system is negative. So coming once again to our equation, we can see that we have negative 66.1 plus 44.0 kilojoule. So adding that up together, it gives you let us go through that once again in our calculation. 66, let me change that into negative. Once again, let me try that. Negative 66, okay, making it negative, yeah, and then plus 44.0. No, let's do it once again. That will be 66.1, which is negative, plus 44.0, giving us negative 22.1 kilojoules. So once again, we have negative 22.1, and that is kilojoules, and that's our answer, for the change in internal energy. So since the change in internal energy, you'll find out that the one and know if it's endothermic, or you check that our Q is negative, so that is gonna be negative. It releases heat, then that is going to be exothermic. So that is for our part. That is our part for B. All right. So that's so we're gonna do that to all the related problems. Now going through, as you can see, we have C, a system absorbs. So you find that absorbing means that it's taking in. So you can just guess what our Q value will be. So absorbs, you can pause and guess for yourself. Absorbed means that our system is the one taking in, and it's so taking in, since it's not work, it's going to be our value for Q. So that is the system that is absorbing. So it's absorbing heat. So absorbing heat means that the Q will be positive. So coming back there, we're looking at the value that has to be positive. That will be 7.25. So that will be 7.25 kilojoules. So looking at 7.5 kilojoules, that is part of the Q. So let us look at W. So W, we're going to use the volume, the pressure volume work. Okay, pressure volume or volume pressure. So that will be negative pressure volume for the change in volume. Now they say that the volume is constant. So because the volume is constant, we have final volume minus initial volume for the change, and we also have initial volume that is equal to the final volume. So the change gives 0. So because the change is 0, it means that when the change is 0, it means that that is 0. So 0 times negative value of the pressure gives a minus 0 work. Now that means that our internal energy, in this case our internal energy will be the Q value plus 0 work. Okay, 0 work done. So that means our work there will be 0. So that means that now we have, you can look once again on the equation, and that will give us the value there. So that is the equation of work, negative pressure times change in volume. So when the change of volume is 0 or the pressure is 0, then it gives us 0 value. So it's Q plus 0. So that will be Q plus 0. And once again we have change in E. Change in E there will be positive 7.25 positive kilojoules. So that is our answer. And then once again, coming to endothermic or exothermic, because our Q value there is positive, then that means that the system or the process will be, in this case, positive for endothermic. So that's how we actually solve problems like this, and I hope that you go through. I've prepared a homework for you, and so that is, we just analyze what we've done: endothermic, exothermic, the systems and the values. I hope you find this interesting. So now you've got a homework to do. So the homework there would mean that you go through the problem for this system. You find that you have a balloon. I need to calculate the change in internal energy of the system. That needs to calculate change in E. And going there, once again, you find that the system is insulated. You solve through. So you can pause through and go through the problem and answer that. And then I'll give the solutions later.